In this video, we will create the final parts of the heat exchanger body so it can be complete. Let's start by adding a flange on the shell. We enter a simple name and description. We move on to the Component Attachment tab. We attach it to the SH1 shell at point 0 and move on to the Design Data tab. We choose the Perform Detailed Calculations option. We input the User-Defined Flange standard. We choose the Integral Hub Flange option and flange type Sketch 6. We uncheck the Vessel in Lethal Service option. And we choose the Calculate Flange Rigidity and Use Bolt Spacing Correction Factor options. And move on to the Geometry Data Input chapter. We enter the flange geometry data. Instead of using B, bore diameter, and hub thickness G0, G1, we use B, BO, and B plus 2 G1, which are the hub diameters respectively. Notice how dimensions G0 and G1 are modified. Now we input the modulus of elasticity. We choose the first option for carbon steels with C less than 0.30%. We choose iron-jacketed mineral fibre for the gasket material. We input the gasket geometry data. We also input 6 mm to raised face thickness. We move on to the bolting data input chapter and select 3/4 inch bolts from the library. We choose SA266 Class 2 as the flange material. We choose to fill the flange with liquid and click on Calculation Details to save the flange. We exit back to the vessel view. Now let's add the next flange. We input a simple name and description and use Component Dimensions Just Like to copy the data from F4. We move on to the Component Attachment tab. We choose to attach F5 to F4. We move on to the Design Data tab. We need to input new values for B and BO. We input B equals 512 mm. We input BO equals 532 mm. We input B plus 2G1 equals 546 millimetres. We input the rest of the geometry data. We input T equals 60 millimetres. We move on to the flange exterior forces input chapter. We choose to calculate the loads from flange F4. We click on Calculation Details to save the flange. Here at WM1, we can see the difference between the loads, which is derived from the difference of hydrostatic pressure between connected flanges. We exit back to the vessel view. Now we will refine the loads of F4 using the loads from F5. We click on Calculation Details to save our changes. We exit back to the vessel view. Let's check on the 3D now. Notice that both flanges have been placed and we are now ready to complete the shell cover. Before moving on, we need to make one more adjustment to F5. We uncheck the Use Shell Nozzle Material of Component Attachment option, and we leave SA 51670 as the chosen material. We exit back to the vessel view. Let's add one more cylindrical shell. We input a simple name and description. We attach it to F5. We input the geometry data. We choose SA 51670 as the material and fill it completely with liquid. We exit back to the vessel view. Finally, let's add the shell cover head. We click on Ellipsoidal End. We input a simple name and description. We attach it to SH3. We choose the post-forming heat treatment option. We input the geometry data. We choose carbon steels with C less than 0.30% for modulus of elasticity. We leave SA51670 as the material. We choose to fill it with liquid. We exit back to the vessel view after saving the component. Let's have another look at the 3D. In this view, we can see the complete design of the body of the heat exchanger. From this point on, we can add saddles, nozzles, etc., but the main body of the heat exchanger is this.